Hello, welcome to episode 138 in this series where I'm programming an NES game from scratch. Tonight I will not be live on Twitch, but that doesn't mean I won't be moving forward. I'm still trying to figure out how I want to handle the development of the game and the progress of the game and all the stuff I've talked about in some of the other episodes. But for now, let's pick up where we were in the last episode. In the last episode, we had looked at how we were going to take advantage of the fact that now we are able to draw 8x8 tiles into the map with the map grid showing the 16x16 attribute grid on top of the map, and use that to give us more freeform capabilities in terms of composing maps versus where we were before with the more rigid 16x16 styles of metatiles. And so we made those changes, and then once we made those changes in tiled to display that grid, and in the asset tool to read in the 8x8 properly, the next thing we needed to do was we needed to see, okay, well, we have those 8x8s. We need to be able to turn those into metatiles of 16x16 and look those up based on if they were used before, so that we didn't have duplicates. We wanted to optimize the use of the tiles and the metatiles, every time. And so what we did here was we built this little loop in the asset tool to iterate through the map and find our 2x2 tile metatile, and then because they're 64-bit values here, which correspond to our 2x2 metatiles, we were able to then just do a simple comparison to see, did we have that metatile already? Because each of the 16 bits that make up the 64-bit value, the four 16-bit values, compose a number that we can just simply compare here. And if we found it, then we didn't add it to this discovered metatiles array. Otherwise, we did, and we incremented the next tile, and then we ended the last stream with checking to see what kind of savings we had on a map where I was just kind of randomly pulling together tiles, and we wanted to see how many individual metatiles that would compose compared to the raw output of the map, which I don't recall how big. This is 32 by 210, and keeping in mind that the 32 is 8x8 tiles, so we want to divide that, in half. So it's 16 and what was 210 and half? 105. I forget what the number was. So 1680 was the total number of metatiles without compression, and we end up with 271 metatiles. Still too many, most likely, but at least we do get a pretty good compression rate there. So we shrunk it down by about 88%, right? 210 is 12.5%. So we could live with that. I think that's a pretty good compression rate for what we're trying to do. you know what we should probably do is we should probably do some testing here. I'm curious to know if we were to do this and just completely wipe the whole map. In theory, what we should end up with is we should end up with a map that is basically going to generate one metatile, right? Let's just test that. Let's make sure that that edge case works. I mean, at the end of the day, you can't have 0 metatiles, right? Because you have to have at least one. And in this case, it's the one that's composed by that one water tile over and over again. Later, please. How come this didn't get updated? Probably because the file is huge. Export as testing.json. That's where this file is, right? Shooters assets testing.json. Yes. Let me. That's interesting that that is. I wonder if it's because of, you know, maybe there are multiple water tile types or values. And that would be something to be careful of, obviously, right? Like where the tiles look the same, but they're not. And that's something that we could optimize further in the tool, right? If we wanted to, we could say, okay, well, you actually have 2 tiles that are that blue color and nothing else. There we go. And, you know, and we don't want that, so we want to optimize for that as well. But I'm trying not to go too deep into that because we could spend many streams. Yeah, cool. So that works. So we just have the one. Spend many streams just trying to optimize for those cases where I'm not sure that I really care about them right now. So then we could do something like this where we have, you know, we say, okay, so we're going to have one that's just the little wavelet in the top corner, and maybe we standardize on, like, that's what we always do when we're drawing to reduce the variability of the metatiles. We might make those something that appear as sprites potentially too, and kind of wink in and out of existence depending on what we want to, you know, what we want to do here. But you can see that looks pretty decent, right? Like that kind of adds some variation to the water. So then if we go to export this, now we should have 2 metatiles. We look at the data here visually. I don't know where we're going to see it. It's probably all at the bottom. So yeah, so there's that 1031, and we will rerun this. Now the part, yeah, so just double check that. Yeah, so there are 2. So we have 2 metatiles there. So that's cool. So that actually is working as expected, but never hurts to check that kind of stuff out, especially with the edge cases where, you know, that like it might mess up because there's only one. When testing regular code, like testing an algorithm that you're writing for, I don't know, anything that you're doing, like fetching a list of values, fetching a list of items to process, whatever it is, you always want to make sure that you're testing sort of your limits. So not only that you get a list of things that you want to process, but that, you know, it doesn't fail if you have 0 things in the list or more things than you expect in the list. That's just kind of good programming in general. All right, so here we have the metatiles that we can compose based on the map information. And then what we had done in the last time was we had confirm that those values that we're looking at correspond to the JPEG that we're using to do the lookup into this image. So that's the next thing that we really should be processing, is we should be saying, okay, now that we have this set of metatiles that we've discovered by processing the map, how do we turn that into a set of metatile files that we can include into the game, right? One of the downsides to the way that this works is that this is explicitly requiring you to specify what the metatiles are. But instead, what we could do is we could generate our own metatiles dynamically. So I think that's what I'll try and do tonight in this stream. Again, keep it sort of on the shorter side instead of the sort of massive streams or episodes that I've done in the past. Kind of work on one problem at a time. And then the plan is to, it's Monday the 28th today, and try and do some more episodes that I can kind of space out, try and do a live stream here or there as well. The only challenge with obviously having both the pre-recorded and the live stream episodes is that then if, for example, I record a bunch of episodes in sequence and then I do them on Mondays and Thursdays, like I had been releasing episodes, then the live streams kind of jump to the future compared to the episodes, which isn't necessarily problematic. I'd be curious to know what people think about that. I mean, it's problematic in the sense that if you're really following closely with the episodes, then you care about the sequence because you want to see, like, okay, he did this that day, and then the next episode he'll do the next thing. The live stream kind of breaks that if I do a bunch of pre-recorded ones and release them in sequence on Mondays and Thursdays. So I might just have to kind of release these as I make them, and then if I'm thinking that there's going to be a lull in my ability to work on things because of work, life, whatever, I can, take advantage of that to space them out a little bit before I get to the next set. So I don't know what I'm going to do exactly there, but let's get to the coding. So let's start with seeing if we can compose metatile files from what we've got here. So discovered metatile information is useful in that these are indexes that are based off of the tile sets that are found here, kind of like before, right? So I've got this JSON file that references the PNG, and it's got the 240 by 384 image size and all that stuff, and the tile height and width. The main thing is that at this point I don't have the tile set information necessarily. Maybe I do. Well, I have them here. So it looks for the JSON file for the thing. So, okay, so that's actually, that might be okay. So if we come out of here for a minute, rerun this and see where we are once we've processed the map, the objects, and the metatile, or sorry, the tile set list. Let's see where we're actually at here. So the next thing we want to do is we want to go through the metatile count, and the metatile count is really the tile layer or the tile set count, right? Yeah. So that's the number of tile sets that we have in the map. I mean, and ideally what we would do is we would just have one with all the different elements we need for a map. Or a set of maps, actually. Where this is just a large palette of stuff that we would want to have available to simplify the process of not having to worry about pulling together the resources. Like, in my mind, you know, I should be able to just say, okay, well, here's all the stuff that's going to be in the game. Let's make that work. And then obviously if there's any sort of tile sets missing, you know, we can enhance the image to include those tile sets so that I can build out what I need to in order to finish or update the map better. Like, so for example, is this just not possible here, or I'm just looking at the wrong? Looks like there's no tile that will let me do. Right, so like this would be a good example of something where I could say to Jordan, okay, just update the image that we're using as our main image for our tile palettes, and add tiles for top left and bottom left. I mean, I might just be missing with the grass transitioning to sand. I have the other way, which doesn't work for me here, but that's fine. And then that's the sand transitioning to grass. And that gives me, you know, sort of a little island kind of motif going on here for that little house there. Right, so like I could say, okay, well, I can't draw these corners properly, and he could update the master image, you know, that has all the tiles to just have that for me, right? And then I patch this up and export it, and then re-export the whole thing using the asset tool, and it'll regenerate all the metatiles and all that stuff. So that's not half bad, I think. That generated a lot of metatiles. Interesting. I mean, I could see that, I guess, with the kind of amount of stuff that got added here. I mean, some of it comes down to also the right now the metatiles don't share content, and that would be an area where we could, you know, benefit from that sort of compression. But anyway, just leaving this alone for a second. So once we get out of here, we have our metatiles that we load. And then what does it do? It looks for the metatile file for the thing, because it presupposes that we made it already. So let's do this. Instead of doing that, let's comment this out. And that's going to load the main. That's going to load the main, the big image thing, right? So, like our master tile palette, essentially. What does that return? Is that a tiger image pointer or just a tiger pointer? Okay. All right. We probably want to free that after this part, but so what I want to do is now with each of these, I'll have to talk to Jordan about my assumption that we could get away with just having one master tile sheet. I think we probably could. And I think that that would work better, because what we could do is we would just have like a combination of the individual tiles and also sort of these little mock-ups of how we wanted to use it, and as long as I was consistent with what I selected, or you know what was selected, essentially that wouldn't be a problem, especially if we then also do the tile comparisons and say, okay, well, all these black tiles are the same thing, so there's no reason to represent them multiple times in the file tile output in the character ROM. So let's see. That's going to give us our tiles, which if we only have one tile layer is just a straight lookup. Excuse me. It's a little bit later than usual for recording this, and I have actually sort of been sleeping at in a normal way. Okay, so that's the first GID value, I believe. Or is that just a global ID? That might be a global ID. All right, let's just go with what I wanted to try here first. So I have this image. I have some content. So I should be able to do, okay, cool. So I can say, so this is a 16 by 16, and then I'm going to blit onto this dest metatile image, right? So I'm going to take the content of the source image, and I'm going to put it onto this metatile destination 16 by 16 because I'm composing the 16 by 16 area based on what I pre-calculated in the loop, and I'm going to put this in, so it's going to be at 0, 0 in the destination. Well, that's actually not true. For now, for the first one, it's going to be 0, 0. I'm not going to loop this. I'm going to just unroll the loop of the copy, I believe. So the source X is going to be what? Do we know how big, how wide the map is at this point? I don't know. We may need to save that out. Map object. Object group. Map width and map height we do. Okay, so this is the source X and source Y. Oh, but that's the map. That's not the image. Oh, well, we know the image size from this thing. And divide it into 8 by 8, right? Oh, let me see something here. That's an integer. Here you go. 1 is by 2, 4, 8. Yeah, so that's dividing by 8 with bit shift. That'll give us our width and height, and then in tiles, in the 8 by 8 tiles, and then from there, what we want to do is we want to say, okay, the index is going to tell us. We're going to have to use the index value to determine what the position and offset, or the offsets for the X and Y are going to be. So let's do this outside of this part here just first, and then we can see how complex this is before we decide if we want to do it right in the blit or not. So we actually do need to do this in a loop for the metatile whatever it's called, discovered metatiles, next metatile. That's a loop because we're doing this for every discovered metatile. All right, so we have our width and our height. This is fixed, that doesn't change. Okay, so discovered metatiles, J. So this is the first value, and I can't remember what order we did this in terms of, let's see, so the first 4 bytes and then the next 4 bytes. Okay. The question is going to be, is that actually going to be in the right order? I think it will be. I think it will be because we're not decomposing the values less than themselves. Like we don't care. We're not trying to grab an 8-bit value out of something that's normally 16 bits. So we don't have to worry about like the order of the bytes. We're just taking our 16-bit value. We want to sorry, hold on. I'm thinking this through. Yeah, so the first 16 bits is going to be the first value. But I'm just confusing myself in terms of, I'll just do this experiment empirically because I think I'm thinking about this right, but I won't know until I won't know for 100% sure until we test this. So the first byte will be, 16 bits, the first value that we're interested in will be this one. And then what'll happen is once we do the first blit, it'll be kind of, we'll just keep doing the same thing, but instead of doing this again, what we want to do is we want to shift this by 16 bits. to shift out the first value and then mask out the rest of it so that it's no longer important, right? We only want the next 16 bits, and then we do the same blit again, and then we got to do that 4 times, and this time it's 32, and then 48, and that would give us, I think that gives us the tile values in the right order. We'll know when we kind of look at the final result of the value of temp as we move through this. So, okay, so the next thing we need to do is we need the source X and the source Y. So the source X and source Y, well, and then of course the width and the height are 8 by 8. So the source width and the source height, I had done this before. So basically the value of the index, if we use a simple grid, let me open up, like I think I remember how I did this properly, but I'll draw it out in case I'm wrong and also to explain it. So normally I just do this on paper, but so let's say we have a 3 by 3 for the sake of simplicity, and I have a value, an index that's 4, 5, 6, 0, so 0, 1, 2, 3, 4. Let's just write all these indices in here. Right, so those are the index values that we can possibly get. And let's say I have a value of 7. Well, looking at it, it's obvious, but if this is a linear array of memory, this is really, you know, this one long contiguous thing that we need to jump into based on a single value. Am I over? Sorry, I'm incorrectly explaining this. Visually, that's what it looks like, and the image is multi-dimensional, right? We have a width, we have a height, and I can't say 5 and just jump to 5 because 5 doesn't actually exist in the image as we have it when we load the value, the image into memory. And so what we need to do is we need to say, okay, well, 5, how does 5 map to the two-dimensional image for us? So the first thing we want to do is we want to say, well, how many tiles do we have across the width? What's the span? What's the stride of the image? And it's 3 tiles, so if we do 5 divided by 3, that gives us 1, right? I mean, it's 1 and some more, but that is correct because that gives us our Y position, right? So it's the index divided by the tile width. And then the next thing we need to know is, well, so that's our Y value, right? Let me write that a little bit more clear. So our Y value is the index divided by the span in width. Obviously, we want to truncate that. Span and width tiles, right? Not the width of the image, but in the 8 by 8 tiles, and we truncate that. Sorry that my writing here is kind of not so great. The X is kind of taking this same idea. So we have the index, and if we do this division, right, we know how many spans we cover. In this case, right, if we have 5, we cover 1 span, so that our Y is pointing to 1, or row 1, since we're 0 indexed, right? By the same token, if we do a index modulo span width tiles, we should get the remainder of how many what's the remainder of that division, and that's our x value that we have to index into that. So like if we say 5 divided by 3, right, we said that's 1 and it looks like 2/3. But if we do, let's do the, I think this is in here. Stop it. Come on. Oh, it's because the pen is sitting on the tablet. Okay, so 5, that's percentage. Does it have modulo on here? Well, if you do modulo, what you're going to do is you're going to get right. So like you do the integer divide, you get 1, and 1 times 3 is only 3, and then there's 2 left. Right, that's the value we're going to get. We're going to get 2, and that 2 corresponds to the x value, which is 0, 1, 2. So hopefully I explained that clearly. So what we would say is we would say temp. What did I say? Temp divided by. I guess we don't even need the height in tiles. We just need the width in tiles. And those are both uint 16, so that will give us an int value, a non-fractional value. And then temp mod tw should give us, oh, except I reversed it. So that gives us our x and y value, sort of. That gives it to us in terms of, in a two-dimensional grid of 8 by 8. And then what we need to do, obviously, is we want to then multiply that by 8 to offset into the image correctly, right? Because we're going to get a value of 1, 2, 1, and the 2 is really the value 16 over here, right? And the 1 is the value 8 over here, and so that gives us our x and y coordinate to do our blitz. So we do that, and then the only thing we need to change is we should be I have the wrong offsets here. So we're just copying it to the 4 tiles in this metatile thing. And then can I save? It's been a while since I've messed with this, so so this will save a PNG, which is what I want. Okay, so let's see if we iterate through this one time what our PNG looks like. Replace file extension metatile file. What's the matter? Image full path. Well, that's not right. I is 0, map metatiles. Oh no. Okay, why is that way? Let's take a look. So metatile count is 1. Metatiles I. Is there actually nothing in there? Okay, did I break that part of the code? I didn't think I don't see it actually doing anything there. Let's open up source tree for a second, because I don't remember, between the amount of time it is and being tired, I don't remember how that worked before. But it looks like it's not actually extracting the right information. So let's see what we've got here. Modified. And there are going to be a lot of changes. Let's zero in on this a little bit better, because I'm kind of looking. Okay, so this is all the old code that we were using. Now I converted this to use new code for extracting some of the stuff, the tile sets and whatnot here, but it looks like, I'm not sure if that's broken or what. So let's just take a look here. Those are the map objects, layers. Go to the JSON file for a second. Yeah, where is it looking at tile sets? That's in here. This gets the tile sets, and then it iterates through them. This is in load map. Which is where we are. Okay, so here are the tile sets. It's loading that stuff up. Oh, okay. This is unchanged. So did I break something by messing with an index incorrectly, maybe? Not that I can see. Let's go to here where it loads the tile sets and see what's going on. M is 0. GID is 1. So it found the TSX file. It's looking for it's going to generate a full path. So it gets the absolute path, which is what we wanted. And then it's going to replace that with a JSON file. It's looking for that. It found it. Get the tile source. Image full path. There it is. That's correct. Map metatiles. Image file name. Get file name. So that isn't set yet. It is now. So that's weird. That all looks correct. So maybe something is getting corrupted. So there's no file info, but the rest of the stuff looks good. It's not an object. Okay. So we're done with that. We go through the layers. Let's just skip ahead here for a second to this free. Oh, okay. So that's where something has broken. So the question is it the no, it's broken before we actually call free. So what's next to map metatiles in the stack? Or is it passed? Map metatiles is passed as a pointer. Let's take a look at this for a second. Map metatiles. No, stop it. Stop trying to guess. Map metatiles. The end. 5A04, 5A04, 5A04. We're seeing a lot of 5A04. So the question is that map data that's been that's overridden the RAM? This is not necessary for what we're doing. Where is, so 5A04, I assume, we're going to find out in a second here. Programmer. Uh-oh. I crashed calculator. Seems like nothing wants to work for me these days. For 5A, that is our culprit. It is map data, 5A04. Okay, so what's happening is our map buffer, I guess the map buffer is bigger than the map buffer size. So let's see. We gotta look at how big this is. That's all. That's probably all it is. Although it should be. Is it allocating it here? I guess it's not. The buffer is just whatever the buffer is. 6720, which is probably too many. Oh, and you know what it is also? Because it's 8 by 8. It's double the size that we actually need. So our map buffer size, it says 0. But what about the map buffer itself? The map buffer, let's see, load map buffer size. The map buffer, where's that declared map max size? So that's 4K, and I believe that size is bigger than 4K. It is. All right, so what we're going to do for the sake of right now is we are going to make this 8K. This is actually not how big it needs to be, because again we're using 16 by 16 metatiles, but the map as it's stored to begin with is we're dealing with 8 by 8 tiles. And then that actually raises an interesting point, which is that we have to go back and reprocess the map to reference the metatiles, once we create them as 16 by 16 indexes, not the existing 8 by 8 indexes. Okay, so that explains why stuff was broken. Let's take a look at this meta. Okay, good. That actually has proper data in it. So we don't need this breakpoint right now. We don't need that breakpoint right now. We're up to this. So we have this metatile. Don't actually know what folder that's going to write to. I'm assuming and hoping it will be this folder. There it is. Let's take a look at that JPEG, PNG, I mean. And it looks like it's a water. That doesn't look right. Let's open this up in something that I can zoom in on it. Properly. So I don't think we actually have any tiles that look like that. We don't. All right, so that means that we have messed up our blitting code. So that was something I said we might be doing based on my not being able to think through clearly the byte order of what we have to process here. So let's take a look at that. So the first thing we're processing is this huge number here, right? So if we look at, again, this is a 64-bit value. What we want to do is we want to take this value. Why are you not? Fine, do it that way. Take this value and break it apart, right? So if you look, it's 045A, 045A over and over again because those are the values. So what we would want to do is confirm that temp is getting 045A. It is getting 045A. Just to confirm, I believe that is a close calculator. That is 1114, which is the value that we want. So then there's something off with the math. The X value, let's take a look at this. So we have temp, and we're doing a modulo of the tile width, which is 48. So the image is how big? How big is this image? It is 384. 384 divided by 8 is 48. Okay, so that's right. So we're getting a x of 10. So 80, right? Because we're multiplying by 8. And then 1114 divided by the stride of 48 gives us 23 as our y value. So times that by 8 and you get 184. So 184 by 80. If we were to turn on our grid here, or actually I don't need to do that because I don't care about the grid right now. 184 by 80. Sorry, 80 by 184. I keep reversing the x and y. 80 by 184. So that is putting us over here, but that's not right because those tiles are from where? Where did I get that blue? It's this. Oh, okay, wait. So I might actually only be off by a little bit. 72 is my... If the value... Let's do... If we do 3, right? We divide by 3 for that, we get 0. Sorry, we get 1 as our y value, and then we do a modulo of 3 against 3, and we get 0 because the x value is 0. So temp is this, and that is 48. And the value is 10. Should it be 9 though? Based on what I'm seeing in the image, it should really be 9, and we get 72 by 184. Why are we off by 1? Oh, because, all right. Well, this makes sense. I just didn't think about it at the time. All of these indexes are 1 based. If you look at this, the starting GID is 1, not 0. So we can just do that. Obviously, you need to add parentheses on the other side. Okay, let's restart, and let's just do this here. All right. It's restarting. Okay. So that should give us just a solid blue metatile now. Okay, great. So that's our first metatile. And then, how many of them are there? There are 19. So let's do the next one. We're not going to go through all of them. I just want to make sure that they kind of look like they make sense. Yep, that was the second one that we created, kind of testing out the edge case of there's 1 or there's 2. So here's the next one. I assume this is going to be part of it's going to have the house or the shore or something like that. Yeah. All right. Let's see. Yep, that looks right. So what we're looking at is that corner, right? And I don't know. Let's do a couple more, just for fun. Make sure that nothing funky happens as we iterate through before we just assume that it's working 100% correctly. Is there no keyboard shortcut? Control page up. Yep, that looks good. And then that's the next corner. So that's cool because we can see that it didn't bother repeating the metatiles. Here it did this first one and then it went right to the corner. What is it? That's the old image. What happened? Did I close it? Yeah. Oh, it isn't the corner. Oh, it is the corner. It's the corner, but it's not. It's the corner, but it's not the corner I was thinking it was supposed to be with the blue, with the water. So I promise I won't do this too much more. I just kind of want to make sure that I'm seeing things that are sane. That is the water corner. We're leaking memory when we do this, so we gotta fix that. There's the side. Now, because we'll have multiple of these, we won't see that again. The next thing we should see is the house. After that, I'll be satisfied that this is working in a reasonable fashion, and we can move on. Yeah, there's the house corner. Right, so if we had multiple houses that we were drawing, that metatile would be reused. Okay. So the reason I was drawing that into a PNG and then saving it was for the sake of... actually, we're not leaking memory because we create the destination metatile one time and then we keep overwriting it. Which, as long as there's no transparency, which we're not using anywhere, there wouldn't be a problem. So the only thing we would need to do here is that. All right, so we just keep doing this, right? We just keep generating this metatile, and then what we need to do is then we have the ability to do something like we could even make this a real metatile, right? TMT. So collision is 0, has collision is false, image. So that's where we would need to take this thing and turn it into a raw image. We'll fix that in this. We'll take care of that in a second. Is that a? That's not. Okay, that's the name and the version. Just leave that alone. Let me see. Metatile. Draw metatile. That draws it onto metatile to image. That draws it into the image. Metatile to image. Tiger bitmap. Draw metatile. Okay. Do I have a image to metatile? I have PNG to metatile, so obviously I have a way of doing it. Load image, convert image to indexed. Load image palette. And then copy. Okay. So convert image. How does this work again? Convert image to indexed, which takes this thing and makes it an indexed image, right? And then what did I say it does next? Load image palette. Oops. Load image palette. So this is our this is our palette destination. So this is going to be the outgoing palette. And this is nothing. And so load image palette. So outgoing, what does that need to be? That needs to be a pointer of UN8. So UN8, outgoing palette of 4. And then palette count. Right. What's the matter with this? No instance, matches argument list. Okay. Stop. Okay, so that will get us a palette, and then after that, that's PNG to sprite. Where's PNG to metatile? That's what I was looking for. And then just save metatile, current metatile. So I'm just going to steal this code. Go back to this, and this is all just 16. Why is it 16? All right, I don't care right now. I guess that's because it's the total palette size. Yeah, I don't care right now. I just want to have this work where it will save the thing. Current image indexed. No, this should be okay. And then save metatile. TMT mic.metatile. So again, we're just testing this out, making sure that it actually saves a reasonable looking metatile that we can load back into this thing. Load image palette. Convert image to indexed. Are they... Okay, I guess I don't have prototypes for them above, so let's do that. Oh, that's weird. I thought I would have had that already. Load image palette function does not take 3 arguments. Palette count. You're right, it doesn't. What gives? Oh, it's this one. This is the one I want. Okay. Cool. So, now, load image palette. Redefinition of default argument parameter. Oh, yeah. You can't do that. One, two, three, four. Initial sprite. Doesn't like this. Okay, that's fine. I don't care. It needs to be null anyway. Convert image to indexed. Where are you? again. Probably just need a prototype for that. What? Convert image to indexed. Why? Why don't you like this? Transparent index. 0. Image. That thing. Indexed. Null. Why? Converted from RGB. If converted from RGB, that's false. I guess. This should really be that. That was for if we were actually converting from RGB versus just adding an indexed, making it an indexed PNG. But if indexed isn't set, then that's not going to work. So, all right. So we have a thing here that got saved. So let's now do this. Metatile. All right. So this is okay. It's wrong, but it's okay that it's wrong. Well, that's not okay. What color is it using? What index? All right, let's take a look at that file. I thought it was wrong, but for a reason that made sense, and instead it's wrong for reasons. So let's see. So the value it's using is DD 221, which is obviously not an index to any of the palettes. It should be convert image to indexed, which it's not re-indexing the image correctly. Let's see. Load image palette. This is calling that version. It loads the image and then converts the image to index, but the image that it's loading, I think it assumes is not already indexed. Oh, I see, but this is a value, so this is an image. It's being loaded from a PNG. I mean, I guess I could, it's kind of awful, but I could like, I guess I could kind of cheat. Leave that alone. And let's see if this fixes it. I think what the problem is because I'm composing the image in memory and it's not loaded from a PNG, and because therefore it's not the same as it would be from loading from a file directly. It's having a problem with the way it's processing the file. I'm not saying that that's right. I'm just saying that that's, I think, what the problem is. So we'll free that, and then we'll load the one we just wrote, basically. And see if that fixes what I'm seeing here. And then if that's the case, we got to look at the data a little bit more closely and figure out what we can do to fix that. So let's save the metatile. Let's take a look at this. Open this again, please. Okay, yeah, so that's right. That's the right value. And if we run this, it's the right thing, right? Like if we do this, let's do this a second. Let's do this 2 times in a row. And then what you should see is, yeah, exactly. So we get the little wavelet at the top there. Okay, so the problem is, like I said, it's that it's loading it from, it's trying to process it from memory, and that's somehow different than processing a file. So the question is, why is that different? It allocates a pix, which is fine. I guess because image transparent index is -1 and image indexed is null. I guess because it has okay, so what we can do is let's get rid of this and this and this, and let's instead fix the fact that the transparent index is -1 or is not set to -1 potentially. Let's see if doing that will fix the convert image to indexed. I think it will. I think because we're not doing a load on the image, it doesn't know what to do here to process it. Yeah, okay, cool. So I was yeah, and then that, okay. Sorry, so I'm like thinking through it and agreeing with myself without explaining. So the fact is that it has the values in the image as RGB values, but because it wasn't loading the file to load in that data, it was not setting that transparent index to -1. So it didn't matter that the indexed array was not null. That raises actually an interesting point about trying to reuse the same memory, because converted from RGB is going to be false the next time through because we'll have those values set. So we'll have to kind of keep allocating and freeing the memory, which not the greatest thing, but well, we could do a couple things to fix that. How does that get allocated? That gets allocated new indexed the malloc. Okay. Anyway, so because it was being loaded from the file, it wasn't being initialized properly here, which meant that we'd get to this point and this converted from RGB condition was not true, which meant that it was not properly handling some of the work that needs to be done if it is converted from RGB. I think that's going to solve for the first metatile the problem we had when we tried it last time. Yeah. Yep. And if we go and we reload the file in the hex editor, yeah, that looks good. So the problem will be the next time around we won't hit this condition correctly. That's going to be false because we're going to have a value index, and the transparent index is, well, that is -1. But this is going to be the problem, I think. Index I. That's -1. Yeah, so that's not. I don't know. Will that work okay now? Yeah, I guess that would work okay now because now it should just do a conversion correctly. Let's see. Maybe that'll work okay. Yeah, okay, that's working okay. So it really was just the issue of the fact that the buffer was not being allocated correctly for the indexed version of the image the first time through, and then that resulted in not generating metatiles that made a lick of sense. So let's see. So that's interesting because that is not, that color scheme is not right. That should be green there. Let's see what the next metatile does. It could be the color choice that is throwing things off, and that's fine. We can, you know, those kinds of things are fixable. Yeah, it looks like maybe that green is not matching to the green that we think it should be, because we're doing, again, the conversion from the RGB space to the equivalent RGB palette, or an equivalent RGB palette on the NES. So there's some room for error there. Let's see what the house looks like. So the house, well, that's close. That's kind of close. Right, it's that kind of orangey red and brown. And you can see that the color of the grass is now actually that blue OC. Interesting. Is the water, or is the rest of the grass being represented by OC as well? And against the water it looks wrong. That's the house there. What, do we run out of colors? That shouldn't be. It's interesting that it's finding more colors than I expected. OC. Okay, yeah, so it's converting the grass to that sort of greenish color. That's not what I wanted to do. And then the water is 1, 2. So 1, 2. OC is that. And 1, 2 is. Where is 1, 2 there? They're not that similar. Let me restart. Let's see if we get a some more house stuff. So something is up with the way that the conversion is happening. I mean, that's clearly... That's okay. That's actually probably what that looks like correctly. Yeah, so that's where I was saying that it looked weird. I think it's because it's somehow being split onto multiple palettes. Like this is index 1 and that's index 1, but that should be this. Sorry, that OC should be this color and not that color. How many palettes does it say? Palette count. Palette count. You're not going to show me because we're outside of the loop. Okay. All right. So let's let me restart this because I'm really curious to. I'm curious to see what it thinks it's getting. Palette count 2. So it just should be 2 values, and then we write that out. And, oh, this is still open. Okay. That makes sense. The next thing we're going to get is that little wavelet form. And that's also 2. I'm not going to bother checking. That says 3. And that would be this. But this color should be here. I don't understand why that's like that. And it's like it overlapped the indexing in a weird way. And yeah, and so that's why we're getting what looks like the wrong colors. Well, and that's even stranger now, because that says that it's using 2, but then the palette is wrong here. 2. It's using a bunch of 2 over here, but 2 is saying 0E. So I look at the palette, so 0E, 1, 2, 3, 7. 0E, and then 0E, 07, 3, sorry, 0C. So this 0E should be really 0C. And then it would work. So something's not right about that. We'll have to come back to that one. We're already in an hour and a half. So we'll come back to that one in the next episode, where we look at why the metatile data is not correct. But we're getting there. We're actually, you know, loading our images out of the main large image and getting something that looks, I mean, the layout of the pixels is correct now. So now the main issue is going to be fixing the colors that are in use. So anyway, as always, thank you for watching. If you want to reach me, I'm on Twitter at Clearvis. I'm on Video Game Sage as Zelius, Xelius. You can also reach me through my email at zelius@gmail.com. Feel free to post comments and questions below on the video on YouTube. I'm happy to answer whatever questions you have. I do have a Patreon if you're interested in contributing to that. It's totally your call, not necessary, but something that I am doing because I've been asked about that, or the Buy Me a Coffee as well. The game, as I've mentioned many times before, is available for pre-order. That gets you access to the source code of the main game engine and assembly, so that you can look at how the assembly code works, and gives you a pre-order of the ROM once the game is finished. Yeah, as always, have a great week, and thanks for watching, and I will catch you on the next one. See you later.